Today we're going to cover section 6-5, solving open sentences involving absolute value. So two things that we're going to cover, solve and then graph absolute value equations in one variable, and also write an absolute value equation if a number line graph is given to you. So we're going one way and the other way today. And this is Algebra Standard 3.0. So kind of recall back to last year, or even the year before that. You remember covering absolute value? Anybody remember what absolute value stands for or what it is? Well, absolute value is, you got it, the distance from 0 on a number line. And yes, it is always positive. So do you guys remember working on these type of problems where they gave you a number in the absolute value bar? So what is the absolute value of 2? In other words, how far is 2 away from 0? Well, 2 is exactly 2 spaces away from 0. So if you think about the number line, here's 0. We've got 1, 2. Positive 2 is right here, and they're 2 spaces away from 0. Okay? How about negative 2? If I go to this side, I've got negative 2. How far is negative 2 away from 0? It is also 2 away from 0. So if you think about this and you take a look, if 0 is right in the middle, I've got 2 away on the right, 2 away on the left. So either way, the number on the inside, it could be positive or it could be negative. Either way, my answer will come out the same because they're both 2 away. Again, distance is always positive. Okay? So if that is true, then what if absolute value of x is 3? Let's say you're 3 away from 0. Where could you be on the number line? If you're 3 away from 0, where could you end up being? Well, think about our number line again. And here's 0. If I'm 3 hops away, 1, 2, 3, I could be here at the number 3, or I could be 3 hops away the other way, 1, 2, 3. I could end up at the number negative 3. Okay? So what could this number be on the inside? What is 3 away from 0? In other words, this 3 here is the distance from 0. So what is 3 away? It could be negative 3 or positive 3. So I could say my x could be negative 3 or it could be positive 3. And I'd write a solution set since there is more than one answer. It could be negative or positive 3. Okay? You may also see people write it this way. This is another way you could write it. X could equal positive or negative 3. Sometimes we say plus or minus 3. It just means positive or negative 3. So it could be written either way. Positive, negative 3 written like this, or then negative 3 and positive 3 separately. Okay? So what have we found out so far? Okay? If your distance is a certain number away from 0, it could be either negative or it could be positive. So there are 2 cases, is what we know right now. Okay? The 2 possible cases are that the inside of the absolute value can be positive or it can be negative. Okay? So that brings us to how we're going to do these problems today. You have to keep in mind that there are always going to be 2 cases, a positive case, negative case. Okay? So example number 1. Okay? So if I've got absolute value of x plus 7 equals 12, what do I know? I know that the value inside my absolute value, this part right here, could be positive. So x plus 7 positive could equal 12. This is my positive case. I could also have x plus 7 be the other case, which would be negative. So it would look like this. A negative of x plus 7 is 12. Those are my 2 possible cases. It could be positive, it could be negative. Okay? So we're going to go ahead and solve both cases. Okay? Positive case, since this is considered positive 1, if I distribute a positive 1, identity. It'll stay the same. So I get x plus 7 equals 12, and I solve minus 7 minus 7. I get x equals 5. In this case, I have a negative 1. I could distribute the negative 1, or another option is, instead of distributing it, since this is multiplication, I could go ahead and divide both sides by negative 1. By dividing by negative 1, I can cancel that out, so it becomes positive 1 times x plus 7 will just give me x plus 7. 12 divided by negative 1 is negative 12. And then I continue solving, minus 7 minus 7, and I get x is negative 19. So what are my answers for this one? Solution set would be x could be 5 or x could be negative 19. Okay? Notice I had to solve two cases though. I had to make the inside part here positive or negative and solve both cases, and I get two cases for this. Okay? So why don't you give this second example a try? Okay, pause here and go ahead and solve that one. Absolute value of 2x plus 4 is equal to negative 8. Okay, so what did you guys get? Well, it's true that you do have to do two cases. 2x plus 4 has to be positive, and then it has to be negative. But this one, I'm going to put a star on this problem right now. This is a trick question. Did anyone catch it? Can an absolute value ever equal a negative? And the answer is no. Absolute value cannot equal a negative number. So since absolute value can never be negative, this is not possible. I cannot have this. Cannot be possible. So since I cannot have this, we call this no solution. So hopefully take a look at your work and make sure that next time you don't fall for this trick. Okay? Okay, example number 3. I promise I'm not going to trick you this time. Okay? So this one is solving graph. Okay? So on this one, besides solving it, we're going to go ahead and graph it on a number line. So keep in mind that the inside, this inside portion right here has two cases. This inside could be positive, in which case I have x minus 3 positive equals 1. I also have the negative case. Okay, and that negative x minus 3 would equal positive 1. Okay, and then once I break it out into my two cases, I solve. Okay, so positive 1, distribute, still be identity, so x minus 3 equals 1. Add 3 to both sides, and I get x equals 4 on this side. My negative case, I can do what I did last time. I can change this to negative 1 times x minus 3. I could either distribute, or what I'm going to do, just like last time, I'm going to go ahead and divide by negative 1. Okay, that way the negative and the negative will cancel out, and I end up with x minus 3 equals 1 divided by negative 1 is negative 1. Add 3, and I get x equals 2. So what are my solutions here? I get x is 2 or 4, and I'm going to go ahead and graph that on a number line. Okay, I need to make sure I have both numbers 2 and 4, and I'm going to go ahead and put a solid circle on 2 since it exactly equals 2, and it exactly equals 4. Okay, and that would be finished. So this would be my complete answer, including the graph. Okay, so what if, okay, we move on to your turn. You give this a try. Okay, so it's your turn. Solve and graph absolute value of r plus 3 equals 10. Go ahead and pause here and give it a try. How did you do? Did you make sure you had two cases, a positive case and then a negative case? Okay, and then from the negative case, you remember to get rid of that negative or distribute it, either way. Okay, you solved, and did you get r is equal to 7 or negative 13? If so, congratulations, you did a great job. Don't forget there are two cases, a positive case and a negative case. Okay? Okay, so we're going to go ahead and move on and try a different type of problem now. Okay, so this one, notice this is a function, f of x. This is back from chapter 4 when we worked on functions, and chapter 3 in functions. F of x, recall, was just another name for y. So really this is saying y equals absolute value 2x plus 1. Okay, so you could write it y equals absolute value 2x plus 1. Okay, either way. Okay, so when we look at this one, you'll if you take a look, it kind of looks like something you've seen before, right? Maybe without the absolute value bars, you remember y equals 2x plus 1 and graphing that slope-intercept form. This is very similar to that. So what we're going to do is apply what we just learned, that anything that's inside the absolute value has two cases. There's a positive case and a negative case. So what happens is, when I'm doing this, I have a positive case of y, or f of x, equals positive 2x plus 1, or I also have the negative case, in which y equals negative of 2x plus 1. And what I would do for this is write it out, so it's y equals positive 2x plus 1. I would identify my slope, which is 2, or 2 over 1. My intercept is 0, b, 0, 1. Okay, and this is what I would graph. And at the same time, I would also have to do the second graph. So I'm going to go ahead and distribute this negative 1. In this problem, I can't divide by negative 1 because I wouldn't have y by itself. I need to isolate the y for slope-intercept form. So I would get y equals negative 2x minus 1. In this case, slope would be negative 2 over 1. My intercept would be 0, negative 1. So what I'm going to do is I'm going to take both of these and graph them on the same graph. Okay, so here's my graph paper. Okay, and then I'm going to go ahead and graph this. So I'm going to graph the first graph, okay, which is y equals 2x plus 1. And you want to make sure when you're doing this graph that you do this in pencil. Very, very, very important. Okay, so I'm taking out my pencil here. Okay, so I've got 2x plus 1, so my intercept is 0, 1, so I'm going to go to 0, 1 right here and put a point. Okay, my slope is 2 over 1, so I'm going to go ahead and go up 2, 1, 2 over 1, up 2 over 1, up 2 over 1, and so on. Okay, and then once I have that, I'm going to go ahead and draw in my line with a straight edge. So make sure that you do have a straight edge handy. Okay, so here's my graph, and I'm going to go ahead and draw this in pencil. Okay, so here's my line, my first line, which is the positive line. Okay, and if you take a look, you'll notice this is a positive line. Okay, so now I'm going to go ahead and graph my second one, my negative case, on the same graph. Okay, so 0, negative 1 is my intercept on this one. 0, negative 1, put a point. Okay, my slope here is negative 2 over 1, so down 2, right 1, down 2, right 1, down 2, right 1, and so on. Okay, and I'm going to go ahead and draw in this line. Extend it just a little bit. Okay. Okay, so these are my two lines, positive line, negative line. Okay, now this is what you have to absolutely check for. Be careful. Since this is an absolute value function, remember back to this equation back here what we started with, f of x equals absolute value of 2x plus 1. Since this is an absolute value, we know that the answer has to be positive. In other words, if I wrote it with y equals absolute value 2x plus 1, the y has to be positive. Okay? Since this has to be positive, that means all answers for y have to stay on the top of my grid. Okay, in other words, all numbers for y have to be positive. So what I'm going to do is check right now. Okay, so y has to be positive. Is y positive here? Yes, it is. It's 0, 1. Positive here? Yes, 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 yes. Everything above the 0 is positive. Now, if I head down the graph, right here, for example, 0, negative 1, is y positive? And the answer would be no, because negative 1 is negative. It's not positive. So since that happens, what we have to do is we have to take out our eraser, and that's why we did this in pencil. Take out your eraser, and what you're going to do is erase everything under the x-axis. So we're going to erase this half and this half. I know this is weird, but trust me on this. It's because it is an absolute value function. Remember how we fell for that earlier problem? Absolute value equals a negative, and it didn't work because absolute values cannot be negative. So since absolute values can't be negative, the same is true for functions. Since the y can never be negative, all your answers are up at the top of this graph. So your graph will look like a V, and sometimes we do call it a V graph. Okay? So your graph will end up being your final answer would be this V graph here. Okay? So this would be your final answer, and it is a V. Okay? So the best thing to do is to do this in pencil when you do it the first time, and then just erase anything that is under this portion, since we know that y cannot be negative. Okay? Okay, so now it's your turn to try this. Okay, keep in mind what we did on our example. Okay, we did two cases, a positive case, a negative case. We graphed each one on the same graph. Then afterwards, we remembered that it cannot be negative, so we erased the bottom half. Okay, so it turns out to be a V graph. Okay, so now it's your turn to produce a V graph. Okay, so let's go ahead and give this a try. Okay, go ahead and graph f of x equals 1/2 x plus 2. Pause here and go ahead and try this. So how did you do on your V graph? Did it turn out looking like this? Kind of funky one, huh? You had two cases. Okay, I wrote them really quickly up here. F of x is 1/2 x plus 2, your positive case, where your slope would be 1/2 and your intercept is 0, 2. And f of x is a negative case, in which case you would have a slope of negative 1/2 and 0, negative 2. And what I did was the same thing, I graphed it, and then I had to erase everything down at the bottom, and the V turned out kind of off-center this time. Okay? Okay, so now we're going to move on to our last examples here, and that has to do with the number line itself. Okay? So, can we go backwards? How do you work backwards? What if you had a number line but no solution set? Could you write one? And how would you do it? Okay? So, very quickly, here's a number line with 0 at center. Okay? Let's say they gave you these 2 points, one here and one here. Okay? Now, if you take a look, could you find the middle of these 2 points? In this case, the middle would be here at 0, correct? Now, you'll notice 0 is right in the middle. This is 2 away, and this is 2 away. Okay? We call these distances. This is distance from 0. So now we're going backwards. You'll notice 0 is in the middle. So since 0 is in the middle, this is x as our center, okay, equals, how far away is it? It is 2 away. So this would actually be our equation for this graph. And this is what you would do to write this, okay? This is kind of a formula. It's not really in your book. You may want to be careful with it, okay? But it works like this, okay? We know that x minus some number is always going to give us our center. We know that x minus n must always equal 0, because 0 is our center usually, okay? And this would happen to equal the distance away. Okay, So what we do is we solve this so that it's always equal to 0. In this case, if I went x and I wanted to make it equal 0, I would go x take away 0 would equal 0, and then x would be my 0. Okay? So we're going to go ahead and give this case a try. Okay? So what if I had this? Okay? I have 2 and 8. What I'm going to do is find my middle right now. So here's my 8 and here's my 2. Okay? What's in the middle? 5 is in the middle. So 5 is my center. Okay? How far away from the center is this? Let's see. This is 1, 2, 3 away. This is also 1, 2, 3 away. So I know my distance is 3 away. Okay, remember it always equals the distance. Now I have to fill this part in. X minus something equals 0. Okay? And in this case, I know my x right now is 5. Okay? So 5 minus something equals 0. What's that missing number? What does this number have to be? 5, did you say? 5 minus 5 would give us 0. So I would write x minus 5. Absolute value of that equals 3. And that would be my equation for this one. Okay? So you're just figuring out what this number is because that's what has to go there. And this x is always your center number. Okay? Because that is the center for this graph. Okay? So now it's your turn. Go ahead and give this a try. Okay, write the absolute value equation for this graph. I've got a point at 2 and one at 10. Go ahead and pause here and give it a try. Okay, let's go ahead and check. Did you get absolute value of x minus 6 equals 4? If you go back and take a look, our points was at 2 and 10, so I found the middle is 6, so my center was 6. Okay, and I know that if my center is 6, 6 minus 6 would give me 0, because that was my center number 6. Right? So 6 minus 6 equals 0, so my number inside the absolute value would be x minus 6. And then my distance would be 4 away. Okay, how did you do on that? Well, it's your turn to try because this evening's assignment, in your workbook on page 79, complete 4 and 5, and on page 80, complete 4 and 5 as well for class tomorrow. Okay, see you tomorrow.